We know that blood flow is critical to life. If our heart stops, we're going to die in a hurry. If we accomplish our goals as we discuss the cardiovascular system, we're going to understand why blood flow is so important. And we're going to be able to apply basic cardiovascular principles to problems related to the cardiovascular system and the entire body. Maybe the easiest way to go about this discussion is to look at a process in detail. And let's take the scenario where we go from resting to exercising at a sustainable level. For example, the intensity you might begin exercising for a 30-minute bike ride. As we begin exercising, there's an initial disruption in homeostasis. Oxygen delivery to exercising tissues isn't sufficient to meet those metabolic needs. So the composition within those cells, within the cytoplasm, changes. That's going to change the composition in the fluid surrounding those cells, or the interstitial fluid. In order to restore the composition of the interstitial fluid, a series of negative feedback loops are initiated in the entire body. And the cardiovascular system plays a critical role in maintaining homeostasis of that interstitial fluid, specifically supplying sufficient oxygen and removing waste, or supplying nutrients and removing waste so that the cells can continue to function. So one of the big changes is that blood flow to exercising tissue increases, and blood flow to more stagnant tissue like kidney and digestive tract will decrease. We want to understand how the body functions to redistribute blood flow to the tissue that needs it most. So we're going to start by talking about the primary function of the cardiovascular system. And I'm going to use a model in which the primary function of the cardiovascular system is to maintain the composition of the interstitial fluid. Then we're going to have a list of learning objectives. We're going to begin by describing the composition of blood. We're then going to look at blood vessel anatomy and talk about how fluid is exchanged between the interstitial space and blood vessels. From there, we're going to look at the relationship between blood pressure, flow, and resistance in a single blood vessel. So understand how blood moves within a single blood vessel. From there, we're going to expand that knowledge to talk about how blood flows through the entire body, all the vessels. And we're going to look at blood pressure in the heart as a pump that generates pressure. We're going to look at the central nervous system and how the central nervous system works with the vascular system to control the diameter of blood vessels and the resistance of those vessels, and consequently flow to any given part of the body. Before we start, you should review the video on homeostasis and negative feedback, the relationship between structure and function, and the video on flow down gradients. If we're successful in accomplishing the goals of this discussion, by the end you're not only going to be able to talk about how blood flow is redistributed to the most metabolically active tissues, but you'll also be able to explain the mechanism of action of common cardiovascular drugs, like those used to treat hypertension, stroke, or heart attack. We hopefully would be able to predict side effects of any of those drugs. And I would hope that you could even go so far as to develop new drugs that would treat cardiovascular conditions like Raynaud's syndrome.